now I would like to put your focus on peering in 2025. And as we as R&D at DE-CIX see how peering will be in 2025 or how it might be. And currently we think it will be an SDN-based IXP setup, and I will go a little bit into detail what we mean by that. If you look into peering of today, you know, it works quite well. We are really successful. Things work as they should do. But if you look a little bit deeper, you realize that BGP is the only API or interface how customers can control traffic flows within an IXP. And BGP is basically unchanged since 2006. So all the BGP versions that are available at IXPs are from these times. And though they are quite limited in the kind of information you can get from BGP, you have just the destination IP addresses and the AS path stuff, but you know, source information is missing and all other kind of information is missing. And yeah, there were quite some endeavors to extend BGP as we have it of today. And a lot of work is done in the IETF about this, and I'm also personally involved in some of this work. But we realize that it's actually quite a cumbersome and hard work to achieve IETF standardization, because you have to make sure that people agree to your improvements, and you have to find a group that support that. Then you have to get the papers ready, and after that you have to convince hardware vendors to implement the stuff. Though the release cycles for improvements are in the multiple of years, in terms of 5 to 10 years time, which is from a point of view, you know, if you want to be innovative, quite a long time. So this is why we need, we see the need for special IXP features that should be available within BGP or some API or interface that allows you to control traffic flows a little bit more in detail. And we think we need greater flexibility in terms of how fast we can innovate and how fast we can develop stuff. And the answer to all this is currently from our point of view, or one answer to this could be software-defined networking. So the basic concept of software-defined networking is that you have the control plane, which means BGP, and the data plane, which is more or less the hardware that does the packet switching, that you decouple this. Because currently today, if you look at a switch or a router, these two parts are, you know, within this router and switch. You cannot change the software that is running on the switch. You can just configure it. So all the features that are available you can use, but you cannot add or change features. And as I said, the SDN concept is to decouple these two parts, so the control plane and the data plane. And if you put out the control plane from the switches and routers and install it on a common server, and if you open up the software stack and you control it in terms of that you can modify it, develop new parts, optimize it, things like that, that allows you to, you know, speed up your development process and be more innovative on the software side. And that's exactly what we try to do. And for this, we have set up a research project, and I will give you a few more details about the research project in the end of my talk. But first, let me quickly explain what we're trying to do with an SDN-based IXP. The idea is that we build, in the first step, an SDN-enabled IXP, which might not be a replacement for DE-CIX Frankfurt, but a small, in the first step, also a prototype, and then later on probably we will start a smaller IXP, like, yeah, I'm not saying that we do it, but like Hamburg and Munich, where we have a smaller instance of our infrastructure running. And then we will replace the software parts that now can be changed easily with our own implementations, or with implementations that are improved for our use cases. And in the next step, we want to provide new features to our customers that are not available today, so that they can control more the data flows within an IXP and all this kind of stuff. And I want to give you a sneak preview about what we have in mind if I talk about new features. I prepared slides for an advanced BGP blackholing that shows you what can be done with SDN and BGP blackholing. And I will also show you a use case, what we call port congestion awareness. And yeah, just let's start on the use cases. The thing for the motivation for blackholing is always DDoS attacks, and you're probably all aware of the increasing number of DDoS attacks we see every day, and not only in terms of occurrences, but also in terms of bandwidth that is used for DDoS attacks. And DE-CIX provided what we call BGP blackholing since 2013 as a free feature for our customers. They can use it, and it works like this. If you are attacked by a massive DDoS attack, what you can do is you can use the BGP blackholing and then make sure that all the traffic that is going to a certain destination IP address from your network is dropped at the DE-CIX infrastructure. But this is a binary decision, so you can only drop all the traffic or none traffic, which means if you drop all traffic, not only the DDoS attack traffic is dropped, but also the legitimate traffic, the so-called good traffic that is of value for your customers. And that's already the right step in the, or the first step in the right direction, but we see that a more fine-grained BGP blackholing might be a better solution for what we see with the DDoS attacks today. And for that, our idea is that we should have the possibility to not only define the destination IP address that is under attack, but we should also have the possibility to define the transport layer ports. Let's say if you are attacked by an NTP reflection attack, then you can easily define the NTP port and drop all the traffic that is coming from an NTP port to your network. Or if you specify or could specify the source IP addresses, so then you can generate a filter for all the open relays, DNS relays that are out there, and drop all the traffic coming from these IP addresses. Other combinations of IP headers could also be beneficial, and we think about different solutions here. But the basic idea is that we need a mechanism that allows to clearly identify the DDoS attack traffic and just drop that traffic, and all the good traffic should go through to the final destination to reach the application. That can be easily done with SDN. If we have SDN-enabled platform, SDN-enabled IXP, that can be easily implemented. And also the next use case, the port congestion awareness use case, can also be easily implemented if you run an SDN-enabled network. And with port congestion awareness, I mean that if you have, in this example, you have an IXP like DE-CIX that is in the middle, and you have three customers, A, B, and C, and the customer A receives IP prefixes, the same IP prefix from customer B and C, and let's assume for BGP it looks like the two different IP prefixes are more or less equal. So the AS path length is equal and all this kind of stuff. So BGP randomly selects more or less which path is selected. But if there is a congestion, or it doesn't have to be a congestion already, but if the utilization of a port connected to DE-CIX is quite high, then it might be the case that this port is selected for the path, even that it's already more or less congested. And if we want to take the port congestion information into account, we have to change things. So with SDN, it's easily doable because with SDN we have all the information already available, and we can implement it into an API like BGP or something else. And this can also be integrated into the route server, and then results in routing paths that are aware of congestions and try to avoid congested paths. So that's our second use case. and we have actually a long list of use cases we see that could be done with SDN easily, that is difficult to do today. And yeah, this is just a selection. So if you want to discuss about other use cases, just have a discussion right after the talk or offline. But let me summarize what can be done with SDN from our point of view. SDN allows you to be very innovative also as an IXP, because it allows you to innovate within software and not within hardware. And you know, changing software is usually a lot easier than changing hardware, as you probably know. And if you are able to innovate in software, which means that your release cycles are a lot shorter, and which means your time to market is shorter. And this also comes with the advantage that you can use additional interfaces or APIs to provide information to your customers. It could be that we enhance BGP or that we introduce new APIs for that. Yeah, so this brings me more or less to the end of the presentation. As I said in the beginning, we have a research project running already since the beginning of this year. This research project is called Endeavor, and it's a European-funded research project. It runs for 3 years, and the research partners are from academia like the University of Cambridge or the Queen Mary University of London. And from the industrial side, we have IBM Research Zurich, besides DE-CIX, of course. The results, and we are already achieved some results, will be available online on the website of the research project, and we are more than happy to discuss our results and also potential partnerships with you. So just come and see me if you're interested in this. So before I close with my presentation, let me quickly point you to our customer satisfaction survey we are currently running. You should have received an email already yesterday about the customer satisfaction survey. If you didn't receive, you can just click on the link to participate. We will hand out Apple Watches, so every 25th answer will win an Apple Watch, and every answer will get a free T-shirt. So please participate in the customer satisfaction survey, because it helps us to get even better. So that's pretty much the end of my talk. So thank you very much. If you have questions or comments, I'm more than happy to answer them.
Happy birthday, DE-CIX. And what we wish for you for the next 20 years is the same outstanding success you've had over the last 20 years.
Thank you, Thomas. Any questions here in Frankfurt? To Thomas, no. Marco, any questions to Thomas from the audience in Istanbul? Marco, any questions to Thomas from the audience in Istanbul?
Sorry, one.
Yeah, we have one question.
Does this new solution create any vulnerability or security threats to this?
Did you hear the question, or?
Not yet.
The question was, does this solution create any security threats to the existing setup, yeah?
So that's a good question. I'm not sure what you mean with security threats to the existing infrastructure. It could be that we replace the existing infrastructure with something new SDN enabled. Though, yeah, that could be a threat. But I think your question refers more to the security questions or the security threats in terms of what kind of threats are then possible if we expose more APIs. That's really a good question in terms of that we spend quite some time looking into that to make sure that the infrastructure we are building or the APIs we are proposing are secure and cannot be mistreated in such a way that you can drop traffic from other customers or things like that. So that's quite important to us, as you know, DE-CIX is quite well known for our security endeavors we are doing. For instance, we are BSI Grundschutz certified or ISO 20001, and we will take the same measures we have in place already at DE-CIX, and we'll transfer them to our new SDN concepts we are working on. And let me quickly, point out that this is a research endeavor. It doesn't mean that we replace the existing infrastructure quite soon. We just want to understand how SDN can provide us new features, new value to our customers, and so we are working on a research project here, and it's not directly linked to production. It might be in the future, but currently it's not.